The largest contentful paint element dictates your entire loading speed score. Identify this element using the Chrome DevTools Performance panel immediately. Look specifically within the Timings section of the trace recording. If the LCP element is an image, immediate action is required. Apply the "fetchpriority equals high" attribute to the image tag. This hint tells the browser to prioritize fetching this resource. This single attribute can save hundreds of milliseconds on LCP time. For background images defined in CSS, the fix is different. Ensure the defining CSS file is part of the critical rendering path. Alternatively, use ~link_rel equals preload as equals image greater than to initiate the fetch early. Remember that slow server response time, or TTFB, often delays LCP. Optimize your backend database queries immediately. Implement aggressive edge caching to reduce latency for all users. LCP measures the time until the largest visible block renders. Render blocking resources significantly delay your largest contentful paint score. Extract the minimal CSS required for above-the-fold content immediately. This minimal set is known as Critical CSS. Inline this extracted CSS directly into the HTML document head tag. Load all remaining, non-critical CSS asynchronously thereafter. Use the standard "load CSS" pattern for this implementation technique. This involves a "link_rel equals stylesheet greater than tag with "media equals print". Add an "on load equals this media equals all" handler to switch the media type. This ensures the stylesheet loads without blocking the initial render. Use "link_rel equals preload greater than for resources discovered late by the parser. Examples include custom fonts or large JavaScript bundles. Preloading establishes an early connection and resource request. This bypasses the parser discovery delay entirely. Never use the "at import" rule within your CSS files. The "at import" rule forces sequential loading and blocks rendering unnecessarily. Web fonts often cause flash of invisible text or flash of unstyled text. These effects impact LCP if the LCP element is text-based. Use "font display" optional to ensure immediate text rendering. If the web font is not ready quickly, a fallback font is used. This prevents layout shift and improves perceived speed. If the font is absolutely essential, use "font display" swap . Combine "swap" with preloading the font file for best results. Preload the font using "link_rel equals preload as equals font greater than . You must include the "cross-origin" attribute for font preloading to function correctly. Self-host your fonts whenever possible to gain control. Self-hosting eliminates third-party DNS lookups and connection overhead. This reduces the time to first byte for the font resource significantly. First input delay measures page responsiveness during the critical loading phase. It tracks the time from a user interaction until the browser starts processing the event. High FID occurs when the browser's main thread is blocked. This blocking is caused by long-running JavaScript tasks. Use the DevTools Performance panel to diagnose these issues. Identify any task exceeding 50 milliseconds in duration. These are officially categorized as long tasks. Long tasks prevent the browser from processing user input immediately. High FID indicates poor interactivity while the page is still loading resources. Remember, FID is only the delay before event execution begins. It does not measure the total time taken to execute the event handler function. To reduce first input delay, You must prevent main thread blocking. Break large JavaScript execution blocks into smaller, manageable chunks. Use "setTimeout" task function 0 to yield control back to the main thread. This allows the browser to process pending user input events. Alternatively, utilize "request idle callback" for non-essential, low-priority work. This ensures execution only happens when the browser is completely idle. For computationally intensive operations, offload the processing entirely. Use a web worker for heavy calculations. Web workers run in a separate thread from the main thread. This prevents them from blocking the user interface. High UI responsiveness is maintained even during heavy computation. This strategy is essential for achieving low FID scores. Cumulative Layout Shift quantifies unexpected visual instability on your page. It sums all individual layout shift scores during the page lifecycle. The shift score multiplies the impact fraction by the distance fraction. Impact fraction measures how much of the viewport was affected by the shift. Distance fraction measures how far the affected elements moved. Common causes include images or videos loading without explicit dimensions. Dynamically injected content placed above existing elements is another major cause. Web fonts causing flash of unstyled text can also trigger shifts. This happens when the fallback font occupies different space than the web font. Shifts initiated by user interaction are excluded from the CLS score. This exclusion applies only if the shift occurs within 500 milliseconds of the input event. The primary fix for cumulative layout shift is reserving space for asynchronous resources. Always specify both "width" and "height" attributes on image elements. Modern browsers use these attributes to calculate the intrinsic aspect ratio. This reserves the necessary space before the image resource loads. For elements like advertisements or injected widgets, define a minimum height. Use CSS properties like "min height 250px" for reliable space reservation. Utilize the CSS "aspect ratio" property for responsive elements. This maintains proportional space without relying on outdated padding hacks. If content must be injected dynamically, place it below the fold. Alternatively, insert it into a container that already has reserved dimensions. Animations and transitions must not trigger layout recalculations. This is essential for maintaining a low cumulative layout shift score. Avoid animating properties that affect the document flow. These properties include "width", "height", "top", or "left". Instead, use CSS "transform" properties for movement and resizing. Use "translate" for positional changes and "scale", for size adjustments. The browser handles "transform" operations on the compositor thread. This bypasses the layout and paint stages entirely. The result is smoother, non-shifting animations. Use the "will change" CSS property judiciously. This hints to the browser which properties will be animated soon. This allows for early layer promotion, but overuse can degrade performance. Time to first byte is the initial metric in the entire loading sequence. TTFB directly impacts your largest contentful paint score. Optimize server-side rendering or static generation to minimize this time. Implement aggressive caching strategies immediately. Use content delivery networks to serve static assets from edge locations. This places resources closer to the end user. Configure appropriate HTTP caching headers for maximum effect. Use "cache control" and "expires" for immutable assets. Utilize HTTP 2 or HTTP, 3 protocols for improved multiplexing capabilities. This reduces connection overhead significantly. Accelerate the delivery of critical resources identified earlier for LCP optimization. Consistent monitoring of these 3 core metrics ensures long-term performance stability.